This is a clutch from a Land Rover Defender, and this is a clutch from a Formula One car. They are remarkably different, and today we're going to show you how they both work and explain why on earth this Formula One clutch costs £6,000, over 20 times more than the one from the Defender. This is the first episode of a new series, Road versus Race, where we show you just how different race car and road car components are, as well as showing you how it all works. So let's start with the road car version, because it's easier to explain the main function of a clutch. It's there to disconnect the engine from the driven wheels, and you need to do this every time you start and stop a car, as well as when you change gear in a manual car. This is because internal combustion engines need to keep turning to keep running, even when the car is stopped and the wheels aren't turning. Clutches also serve another purpose though. They're also there so you can smoothly pull away. Without being able to smoothly deliver power as you gradually lift the clutch pedal, the car would either stall when you jammed it into gear or lurch forward suddenly. The clutch enables you to gradually bring the gearbox up to the engine speed, and the same the other way round when you're going down the gearbox. So here are the two bits. This is called the pressure plate, and the other one is called the clutch friction plate, sometimes called the clutch disc. This pressure plate is bolted directly onto the flywheel on the back of the engine, and so is spinning when the engine is running. The clutch disc is then sandwiched between the pressure plate and the flywheel, where this spring, called a diaphragm spring, essentially clamps the clutch disc between this surface here and the flywheel. The gearbox is then connected to this spline in the center of the clutch disc, which sends the power to the wheels. So the clutch plate sits between the engine and the gearbox. So the pressure plate is on the flywheel. This clamps the clutch disc, which then powers the wheels. So how does this send drive from the engine to the gearbox? Well, this is the reason why the clutch disc is covered in this black material. It's a high friction material that is similar to the stuff in a brake pad. It's there to offer maximum grip. The one we have here has served its 100,000 miles or so, and it's completely worn down. A new one looks more like this, with nice thick material on it. This material is on both sides too, and it is what enables the drive to be transferred. So when the pressure plate is mounted to the flywheel, this spring pushes hard on the contact surface on the inside here and clamps both sides of the clutch plate and sends power through the central spline here to the wheels. That's all when the clutch pedal is up, but what happens when you press it down? When the pedal is down, you push hydraulic fluid through the master cylinder, which acts on a slave cylinder that presses down on this area of the diaphragm spring. Now, this bit is counterintuitive. When you press on these central fingers, the spring in here buckles inside out and actually releases the pressure from this contact surface here. This then removes the clamping force and allows the flywheel and clutch disc to spin at different speeds, so you can stop without stalling the engine. This, of course, is fairly simple, but it is hard to picture without actually seeing it. Now, this clutch has a really strong spring, so even if I stand on it, it doesn't disengage. And this makes sense because a Land Rover has a decent amount of torque, and so the pressure needs to be high to make sure the clutch doesn't slip when you're towing or off-roading. In a hatchback, this spring would be much softer. So why are they so big, especially when compared to the Formula One clutch? Well, in a road car, you aren't focusing on minimum weight or maximum power delivery. It's about being able to feed the power in smoothly and minimizing cost. They also have to think about keeping the spring pressure to the minimum possible, because you're balancing the amount of pressure needed to hold the car's power whilst not making the clutch pedal so stiff that it's like doing reps on a leg press when driving around town. This is actually what my first car was a bit like. The clutch springs are often so close to the edge of holding stock engine power that if you customize the exhaust or engine components and increase power slightly, you may have to change the clutch too, so that you're not slipping the clutch all the time. Also, in a road car, you spend a fair bit of time using the clutch to stop and pull away, as well as changing gear, so having a nice smooth clutch enables you to control the car much better. This is because you are actually slipping the clutch a lot of the time, so the car needs good pedal feel to control this. When you're pulling away, the bite point is where the clutch plate first grabs on the flywheel. At this point, the flywheel is traveling at a certain speed and the clutch plate is moving, but slower than the flywheel. Then, as you bring the pedal up, you're slowly applying more clamping pressure and bringing the clutch plate up to the speed with the flywheel. One question you might be asking is, what are those small springs for? Well, these are here to make sure the clutch release is smoother. If I show you the clutch plate side on, you can see that it's actually two plates, one with the friction material on and one with the drive spline in. The springs are what connect the two, so when power is applied to the outer plate, it compresses the springs and then softens off the power delivery to the spline, meaning the car doesn't lurch away when you release the clutch. This also reduces wear on other components in the drivetrain as well. So that's the road car clutch. It's pretty big and heavy and fairly cheap, around £500 for an average setup. Its main focus is smooth power delivery and easy operation. Now let's look at the F1 clutch. This is an entirely different beast. First up, look at how small it is compared to the road clutch. It also weighs less than a quarter of what the road clutch does. There are two reasons why it has to be so small. Firstly, small things are generally lighter, and that is always important when putting a Formula 1 car together. And the second reason is that this is mounted to the back of the gearbox, very low in the car. Making the diameter smaller allows the engineers to mount the engine and the gearbox lower in the car, and therefore lowering the overall centre of gravity and improving handling. This is particularly important as the engine and gearbox make up a large majority of the weight in a Formula 1 car. It's mounted so low that if you were to cut a hole in the floor and fit this normal clutch in there, it would be scraping on the track surface. Whilst it's smaller and lighter than a normal clutch, it also has to deal with higher temperatures over 500 degrees C and over 1000 horsepower, probably close to 10 times what this one can hold. So to make up for the smaller surface area on this clutch, there are several plates. This clutch has 8 of them, 5 driven plates and 3 driver plates. You can see them here through the side of the clutch housing. This gold part we call the clutch housing. Then the clutch plates are in here. The driven plates are the larger ones that, if you look carefully, are keyed into the clutch housing, so these parts move together. Then the driver plates are the smaller ones that you can just about see in the middle. These are then connected to a central hub that is connected to this shaft here. We also have the titanium clutch mounting bracket and the slave cylinder here. This is what operates the clutch when the drivers use the clutch paddles on the steering wheel. So how does it all work? Well, it's essentially a very similar principle. Pressure connects the plates together and transfers drive. Removing the pressure disconnects the drive. And one difference is that F1 cars don't use flywheels anymore, so the engine connects directly to this shaft here, which goes through this part and connects to the center spines on the clutch center hub. This is the part that holds the 3 smaller clutch discs and carries the drive from the engine. Right now the clutch is engaged, and so I can't rotate this shaft as there is pressure holding all of the plates together. So how do you disconnect the drive? Well, that's what this cylinder is for. This pushes on this teardrop shaped piece, which then pulls on the diaphragm spring. The diaphragm spring on this is similar to this one on the road car, just the other way round, so you pull on it rather than pushing to disengage the clutch. When you do this, it only separates the clutch plates by around 3mm, but it's enough to allow them to disengage and disconnect the drive. Then when the cars are on the grid, the clutch is held until the lights go out, where the drivers slowly release the clutch. This releases the pressure on the diaphragm spring and clamps the clutch plates together. Now, this multi-plate system with carbon discs is a way of holding incredible power. If you were to fit one of these to a normal road car, the drive would be very jerky, making the clutch pedal feel like an on-off switch. But that's not what matters on a Formula 1 car. It needs to be very small, light and hold incredible power, and that's why it's been designed like this. Now, after all that, it should be fairly obvious why this costs over 20 times more than the road car clutch. The majority of the cost is for the design. These things need to work flawlessly in some of the harshest conditions. This means that they take hundreds, if not thousands of hours of development with a team of some of the most talented but expensive engineers out there. And they are also made from very different materials. The plates are carbon fibre and the majority of the metal here is titanium. Where steel costs around £1 per kilogram, titanium costs 35. And this clutch housing, for example, has been meticulously machined out of a solid block of material, using a lot more material than a cast steel version, as well as taking a skilled machinist to do so. Look at all of the scalloped areas here, all to reduce weight. But the biggest reason is economies of scale. The road car clutch is shared across a bunch of cars, meaning they probably make tens, if not hundreds of thousands of them every year. You should watch this video here where I compare F1 brakes to road car brakes, and the difference is absolutely incredible. Be sure to subscribe to follow this series, and I'll catch you in the next video.